We'll move right on to our next keynote speaker, and perhaps if there's time at the end, we'll have some Q&A. But it is often apparent that those who would argue that humans are creating a global warming crisis are missing the forest for the trees. As Dr. Balling demonstrated, anecdotal or isolated incidences of dynamic weather do not necessarily mean that the Earth is in store for an imminent global warming crisis. Similarly, it is often apparent that those who argue that humans are creating a global warming crisis are missing the trees for the forest. Bent on showing that their predictions of imminent climate catastrophe are about to materialize, they often ignore basic data from many scientific disciplines that indicate otherwise. Our next speaker is one of those scientists who likes to examine each of those individual trees one by one. He has shown that statistical models offered to support alarmist global warming scenarios have been deeply flawed. He has applied statistical and economic analysis to demonstrate that real-world temperature observations do not indicate an impending global warming crisis. In short, our next speaker is able to bring to the scientific discussion many important angles that other climate scientists miss. He is an associate professor of economics at Canada's University of Guelph, where he specializes in environmental economics. He has published dozens of peer-reviewed journal articles on a wide range of topics, including the economic theory of pollution policy, economic growth and air pollution trends, climate policy options, the measurement of temperature and climate change, and statistical methods in paleoclimatology. He has given policy briefings to the Canadian Parliamentary Finance and Environment Committee and to the government staff for the U.S. House of Representatives and the U.S. Senate. In 2006, he was one of just 12 experts from around the world asked to brief a panel of the U.S. National Academy of Sciences on paleoclimate reconstruction methodology. He has discussed climate change on Canadian and British national television, and his climate change analysis has been published in the world's leading newspapers and news magazines. Ladies and gentlemen, Dr. Ross McKitrick.
Okay, now if we're lucky, I will find where my presentation is. All right. We're in business here. I apologize about the title. It's a bit of a mouthful, but I want to draw for my talk on a paper that Pat Michaels and I published recently, and I couldn't think of anything better, so I just went with the title of the paper. The issue, and there's going to be a bit of overlap here with Bob's talk, so I can skip over some of the preliminaries, is the famous graph of the global temperature. And the issue that particularly interests me is that what people are actually looking for when they construct a climatic data series is different from what they're actually measuring. So you have access to temperature data, and it might be data collected at airports or out in the forest or wherever you happen to put your thermometer, but what's being sought is something other than today's air temperature. If you walked out in the middle of Broadway, for instance, you took the air temperature, you can obviously get the temperature reading, but if you wanted to know the climatic parameter or the climatic value, what you're trying to do is figure out what would be the air temperature today if this building didn't exist, if this whole street was never settled, if this was still the middle of a forest. Basically, if nothing had changed over the past few hundred years. And so the climate data that people are trying to construct is a measure of a pure climate signal. What would be the temperature if none of these other things had changed over time? And so there are obviously some problems if you're going to try to construct that kind of data. You have all the issues of urbanization that Bob talked about, the land use changes, all those things. You also have uneven sampling over time. I'll show you a few pictures of that. You've got staff and equipment changes and discontinuities, just switching over from mercury thermometers to electronic thermometers, as Bob talked about. These all produce changes in your data series, and you somehow have to filter those out to get at this elusive long-term climate signal. Now, here's a picture of the station coverage as of 1885. This is from the Global Historical Climatology Network, and this is a graphic that was posted by John Goetz on Climate Audit not too long ago. And if you just look at this is the locations of weather station records available for constructing these long-term averages. So 1925, well, you filled in the United States pretty well. There's lots of data in Canada, and getting through Europe and Asia. 1945, 1965, and we're more or less at the high point of the network. By 1985, it's starting to fall off again, and then by 2005, the lights have gone out, so to speak, over much of the world, and even up there in Canada. I don't know how we somehow lost track of all our thermometers in Canada, but I guess they all froze or something, but the data is not being submitted to the GHCN. Now, this sampling issue raises another problem, which is that there's a big drop-off in the number of records, at least the number of records being submitted to the Global Historical Climatology Network. Presumably the data is still being collected somewhere, but it's just not being made available for the construction of global averages. And there's a big drop-off around 1990, coinciding with the collapse of the Soviet Union. The blue line there shows the number of stations in the GHCN record, and you can see it falls by about half over a 4-year period. And at the same time, the raw average, the uncorrected data, shows a big jump about the same time. So that's fine. The people who work with the data know that they had a big change in the location of the sample and the spatial extent of the sample, so they come up with an adjustment. Well, the problem for the interpreter of the data is if we start setting all these records around in the 1990s, we start seeing all these records that consist of a change in the mean, does that mean that the actual mean changed or the actual climate changed, or does it mean the adjustment's just not adequate? And there's no way to answer that question from first principles. You just have to go, you have to trust in these adjustments. Now, data coming from cities and towns and villages, they can be affected by all the buildup of the landscape and the quality control problems and the waste heat and so forth. That's the urbanization issue. And it's in the background of what this study is about, but I want to emphasize this is not just a look at the urban heat island effect. This is a look at overall data quality issues and the overall problem of trying to identify that long-term climate signal. Now, with respect to identifying the climate signal, this has been recognized, it turns out, for a long time in meteorological literature. So this is a quote from J. Murray Mitchell back in 1953, who was talking about, at that time, his work with these long-term temperature records as a means of measuring climate. The problem remains one of determining what part of a given temperature trend is climatically real, and what part the result of observational difficulties and of artificial modification of the local environment. So he identifies two categories of issues: the artificial modification of the local environment, which nowadays we'd refer to as anthropogenic surface processes, and observational difficulties, or as we call them, inhomogeneities, so the quality control, equipment changes, that sort of thing. And there's a lot of studies, a huge literature on the challenges of taking temperature data and producing climatic data series. The literature just on the classical urban heat island effect is very large. And just to kind of summarize this point before getting to the statistical stuff, remember that when you look at a climate data series, behind it, the assumption works out to something like this. You've got temperature data that a lot of it's coming from the wrong places, from cities and airports and places you don't really want to be measuring it. And then there's some fancy adjustment algorithm, and the output is this perfect record. And if you're happy with the first two steps, then nothing that I say for the rest of my talk is going to impress you greatly. But if you think that there are some assumptions in those first two steps that deserve a second look, then stay tuned. Now, the adjustments that I'm talking about here are not trivial. At least in the United States, it can be said that there's an empirical basis to them because there are so many weather stations here. You saw on that map, it's a very densely sampled region of the Earth's surface. And with all those weather stations in close proximity, there's some scope to estimate how much of a change in a particular record might have been due to particular changes in the landscape around that weather station. But outside of the United States, there isn't nearly the empirical basis for doing these kinds of adjustments. However, if those adjustments were successful, if you could get all that information and filter out all the things in the data that are related to non-climatic effects, it would imply that the temperature trend from a region should be uncorrelated with measures of socioeconomic development in that region, unless it's just they coincidentally happen to move together. But there shouldn't be a systematic correlation between those two things. There's a pair of papers by a Dutch team, Joost de Laat and Achilles Morales, who looked at this question of whether climate models, if you look at the spatial pattern of warming at the Earth's surface, do they predict that that spatial pattern of warming will look like the spatial pattern of industrialization? And their answer was no, that is not a prediction from the climate models. Where the warming is supposed to take place, Bob mentioned places like, well, remote uninhabited places like Western Canada and Siberia, those are not places where we associate with rapid industrialization over the 20th century. So that correlation should not be there, but it is there in the data, as they emphasized, and as Pat's and my work will show. The spatial correlation is very strong, and that gives us a strong signal that the kind of data that's being used to measure climate change still has non-climatic contamination in it. The IPCC report, they acknowledge the urban heat island effect, but they say it's a strictly local problem, and don't worry, we've got it all taken care of, and we've filtered it out, and nothing to see here, folks, keep moving. Well, that's fine. That's their stated hypothesis, and what it means is that the non-climatic biases due to these general surface processes have been removed. So now we have a discriminating hypothesis which allows us to do some statistical testing. The spatial pattern of land-based temperature trends in the IPCC gridded data should be independent of the socioeconomic conditions in places where the data are collected. Now, in a previous study that Pat and I did, we took 218 individual weather station records and the corresponding, what's called the CRU gridded data, or the gridded climatic data series from England, for all those same locations, and we tested both series. And we showed that on a spatial basis, the weather station data and the IPCC gridded data show very strong imprints of a lot of socioeconomic indicators for those regions. And because the station data is the input to the IPCC climate data, that means that these adjustments that are being made are not adequate to remove these non-contamination biases. In the new study that we published in December, we had a complete sample of all the available surface grid cells, and we again compared the spatial pattern of warming in the grid cells to spatial pattern of socioeconomic covariates, and again we can reject this independence hypothesis at very high confidence levels. And we also could show that these non-climatic signals add up to a net warming bias in the global average. Okay, so getting into some of the nuts and bolts of the study here, we're looking at, in each grid cell, we have a trend, a number which represents the warming or cooling trend over the period 1979 to 2002. And so each grid cell is represented by a number. It might be something like 0.12, for instance, and that means 0.12 degrees per decade warming for that location. Then we have a statistical model, and we take that trend, call it theta in this case, and we're going to suppose that it's the sum of three things. It's the sum of the true climatic trend, which we want to measure. It's the sum of the effects of the surface processes and the effects of the inhomogeneities. And they all add up, and what we want to do is try to unravel those last two and see what we can say about that first one, the true climatic trend, which is what we're trying to measure. Now, again, the IPCC's maintained hypothesis is those last two are not features of the data, so we can ignore them. Now, this moves into the mathematical representation. For the surface processes, we measured them using, for the same grid cells, the growth in population density, growth in real average income, growth in real national GDP, and growth in national coal consumption. And the inhomogeneities, bear in mind, you can reduce them only if you spend money on it. If you have a lot of money to spend on a weather monitoring system, which is the case in the United States, you have a lot of money to spend on it, then you've got a high chance of doing it right. You can sample in a lot of locations, you've got the staff to maintain all this equipment, but if you're in a country that has very few resources for meteorological work, you don't have a lot of skilled workers, you don't have a lot of technical equipment, you're going to have fewer resources to deal with the inhomogeneity issues. So our measure here was GDP density, or GDP per square kilometer, and the availability of educated workers, in this case meaning the sum of the literacy and post-secondary education rates. And the GDP density here, it means, in effect, if you have if you're in a country with a high GDP in a small land area, you've got a lot of resources per square kilometer. But if you have a very small economy spread out over a huge land area, it's going to be harder for you to afford to monitor your entire country properly. Now, the ideal temperature, we can't actually measure that. I mean, if we could, then we wouldn't go to all this trouble. But what we want to do is argue that the true climatic trend could be represented as a function of the available climatic series that we have available. So we have the tropospheric temperature measurement in that grid cell, air pressure, measurements of the, whether it's a predominantly dry location or a moist location, proximity to water, and latitude. And that gives us a regression model. And if you get into regression details, you might be interested in knowing we estimated this using generalized least squares with a clustering robust standard error matrix to control for heteroscedasticity and error clustering processes. And these are the results. The part to concentrate on is that boxed area in the list of coefficients. If it's a bold-faced coefficient, that means it's statistically significant. Now, the hypothesis that all these surface processes and inhomogeneity indicators don't matter would imply that those should all be zero. But instead, they're large and statistically significant. And then we can calculate what's the probability that they really are zero and we just happen to get these effects by chance. And the probability of that is 7 times 10 to the minus 14. Or in other words, it's 13 zeros and a 7 tacked on the end, which you could probably round down to 0. So in other words, we can conclude with a high degree of confidence that the surface grid cell data are contaminated with these non-climatic factors, even after the adjustments have been applied. Interestingly, the population effect is very large in this data set, and that's after one of the few adjustments that is consistently made, supposedly, is an adjustment to remove the effect of urban population growth from these data. So we find that even with that adjustment in place, there's still a large population effect. Okay, now, with this kind of study, you can anticipate you're going to get all kinds of charges thrown back at you about, well, you didn't test for this and that. So I pretty much ran through the whole list. We did bootstrap resampling to check the error distribution, removed outliers and re-estimated everything, checked for nonlinear structure in the errors, test for endogeneity or a direction of causality bias, which is a serious problem in regression models, and checked for a spurious result by switching the tropospheric data over to the dependent variable side, because presumably those effects should disappear if we're working with data from the mid-troposphere. And for the most part, they do, except for the coal consumption effect, which is still there in the troposphere. The out-of-sample prediction test, that means we got rid of a bunch of our data and saw how well we could predict the data that we removed from the sample, did this over and over, and find we can accurately predict the remaining data in our sample. These are all tests of the specification. And overall, what it allows us to argue is that this is not a spurious result. These are not statistical flukes. This is a very real pattern in the data. Now, using the regression model, you can then back out the effects that shouldn't be there. And this diagram here shows the distribution of observed trends in the raw data, that's the top panel, the distribution in the satellite data, the second panel, and the distribution in the surface data if you use the regression model to filter out all these sources of contamination. And you can see that the average surface trend drops in the sample from 0.3 degrees per decade down to 0.17 degrees per decade as a result of this filtering. So the non-climatic effects, these contaminating sources, explain about half the observed warming over land since 1980. Now, this paper was published in Journal of Geophysical Research in December, and includes this diagram, which shows the differences between the observed and our adjusted trend records. And one thing you can notice there is how many areas of the world, especially in Africa and Greenland and South America, where there still isn't enough data to identify a trend in the post-1980 period. Okay, so obviously we come in for some criticism here. I was actually expecting that by the end of December, people would have completely abandoned the gridded data sets and moved on to something else, but that didn't happen. The first criticism we got was on the Real Climate website, which boiled down to saying, oh, this is all due to spatial autocorrelation. Now, that's a term that means a change in one grid cell should be correlated to what's happening in the surrounding grid cells. And if you take that into account, or if you fail to take that into account and it's a real problem in your data, that will artificially boost the significance values in your calculations. So I thought, okay, fine, we will add in that test. It was a bit of programming work, but it tested the residuals for spatial autocorrelation, used a good, widely recognized Lagrange multiplier test for spatial autocorrelation, allowed for the 3 different weighting schemes that are standard, and in no case in either the 2004 paper or the 2007 paper was there evidence of spatial autocorrelation. Then I reran the model anyway, allowing for spatial autocorrelation, and the coefficients and the conclusions all just come roaring back. So I wrote that up in December, just as a quick note, sent it to Journal of Geophysical Research, and the editor wrote back a nice little email and said, well, this is nice, but basically it's a reply to a comment that nobody submitted, so I can't do anything with it. So then I sent it to Rasmus Benestat at Real Climate, who'd audited the blog post. We had a very pleasant exchange of emails, and I said, okay, well, this is where it's stuck. So would you mind writing up your critique as an article and send it off to the journal so then it can be peer-reviewed? And I got a very pleasant email back. Oh, you know, happy Merry Christmas, blah, blah, blah. I should tell you, I'm getting more and more strapped for time, both at work and at home. And, well, that was the end of December, last I heard from him. So I'd still like to publish this thing, so if any of you would mind writing a critique of our paper and sending it to Journal of Geophysical Research, then we can get the ball rolling on that. The second critique, I didn't realize that the IPCC had actually mentioned Pat's in my earlier paper until an email from Joost de Laat, who was startled by this paragraph in the report. I'll get to it in a second. During the review stage, I was an expert reviewer on the Working Group 1 panel, and I and others had pointed out this literature and said, listen, guys, this is your fundamental data set here. You have to address the problem of data contamination. It's pretty well established now in the literature. So this was the response to review comments by the chapter authors. The locations of socioeconomic development happen to have coincided with maximum warming, not for the reason given by McKitrick and Michaels, but because of the strengthening of the Arctic oscillation and the greater sensitivity of land than ocean to greenhouse forcing owing to the smaller thermal capacity of land. The irony here is you have statistical evidence of a strong anthropogenic but non-greenhouse warming factor in the data, and the IPCC's response is, no, 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 it's natural causes. They don't even invoke the Arctic oscillation to explain what's happening in the Arctic, but here, they're invoking it to explain what happens on all continents right down to the southern tip of South America. So it's an amazing thing, this Arctic oscillation, what it can do. In the final version of the chapter, it's there on page 244. This is what they put in. McKitrick and Michaels and de Laat and Morales attempted to demonstrate that geographical patterns of warming trends over land are strongly correlated with geographical patterns of industrial and socioeconomic development, implying that urbanization and related land surface changes have caused much of the observed warming. Now, if you take attempted to demonstrate and just replace it with showed, then that would be a pretty good summary of what's out there in the literature. However, the locations of greatest socioeconomic development are also those that have been most warmed by atmospheric circulation changes, and they refer to some sections of the report later on that don't talk about what this is talking about, but it's still kind of remarkable to me that the IPCC claimed that the data contamination patterns are spurious and insignificant is simply a fabrication. There's no evidence that they can cite in support of it. And this isn't a trivial point. We are talking about the fundamental data set that they use for drawing all these other conclusions, and they're remarkably casual about the quality control process here. And to be specific, once again, including these circulation effects absolutely does not change the results as they suggest. So the current picture that we can look at this point is the gridded climate data collected over land is contaminated with a strong warming bias that explains about half the observed post-1980 warming. It's been established across multiple publications using independent analyses of independent data sets, and to my knowledge, there are no credible rebuttals to these findings that are in print, and so I think we are entitled to take it as read that these global temperature data series collected over land include a warming bias that is overstating the magnitude of the problem. Now, I had, in my initial emails with the Heartland folks, I said this is what I want to talk about. There are also some suggestions about, oh, well, would you also talk about blah, 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 all these other things. And I think since we're running a bit out of time and we want to get on to the other sessions, I'm going to skip over the other brief comments I wanted to make, and I will just go to the promotion for my book, Taken by Storm, which co-authored with Chris Essex. The revised edition is now out. It will be shipping in the United States shortly, hopefully in another month or two. You can order it from Canadian bookstores. But you can get information at takenbystorm.info or at my Google Pages website, which is there. Thank you.
Thank you very much,